Page 3. We're talking about rates of change today. On the page 350 reading, we're going to fill in some blanks here. A rate is a comparison, sometimes a ratio, between two quantities with different units. For example, speed is a rate between change in distance in the numerator and time in the denominator. If you drive to São Paulo from Campinas in 1 hour, your average speed is 100 kilometers per hour. But what is your instantaneous speed when you were leaving your house? Like, what was your speed as you were leaving your house? Well, in my house, I can't drive 100 kilometers an hour, so I would say it was 20 kilometers per hour. And then it asks you, what about when you were passing a car on the highway? So maybe you're going to go like maybe 120 kilometers per hour. And finally, when you were driving on a city street before reaching the highway, how fast were you going? Maybe like 60 kilometers an hour. The instantaneous rate of change of a dependent variable with respect to the independent variable at a particular instant is given by the gradient of the tangent to the graph at that point. So you can see, like, this is kind of like the distance traveled when we're going from Campinas to São Paulo, because it's like not a steady rate of distance traveled. It varies, you know, if you're in the city, or if you're on the highway, if you're pulling out of your driveway, if you're passing a car. So the distance covered is going to, you know, come in fits and spurts like this. And then if you ever want to figure out the velocity at a certain point, you draw a little triangle like this, and you find what is the slope at that point. But it's a curve, so there's not really a slope. What you can do is you can draw a line, a straight line, that touches the curve at one single point, and then you could find the gradient of that line. So you're indirectly finding the gradient or the slope of the line by drawing this little triangle here. So this is a tangent line because it touches at one point, and you're going to find the gradient or the slope of the tangent line. Now, a chord of a curve is a straight line segment when joins any 2 points on a curve. You can see a chord is different than a tangent, because a tangent, you can see, touches the curve at one single point, and the chord touches at 2 points. So here's the tangent at A, and here's the chord between A and B. The chord AB measures the average rate of change for a given change in x values. So contrasting with a chord, a tangent is a straight line which touches the curve at only 1 point. The gradient of a tangent at point A measures the instantaneous rate of change at point A. As B approaches A, so if, like, these 2 points get closer and closer together, the limit of the gradient of chord AB will be the gradient of the tangent at A. Okay, so let's fill those in. Now we're going to use the fact that, you know, if you make the chord smaller and smaller and smaller, eventually it gets to the point where it's the same as the tangent. So we can use that limit to estimate the gradient of the tangent. Okay, so here we got y equals x squared, which is your basic parabola. Okay, and we're going to consider the point 2, 4, which is, let's say, right there. Okay, and we want to know what the gradient of the tangent at 2, 4 is. Okay, now we can draw the tangent or sketch it pretty easily. It looks kind of like that, right? And our question is, what is the gradient at that point? So we're going to use the chord to estimate it. So we're going to draw a chord which is going to connect this point to another point, maybe up here, point B, and it's going to be like a little bit steeper like that, right? And so depending on how far away this B value is, the slope is going to be much different than the tangent, and when the B gets very close to A, it should be almost the same as the blue tangent line, the gradient of the blue tangent line. So we're going to do it first with b on the right, and then we're going to do it with b on the left. So the first thing we're going to do is we're going to say that, okay, the x value for b is going to be 6. Okay, so that's pretty far away from the x value of a, which is 2. Okay, so what is the point b? It's going to be 6 comma something. So 6, if we put 6 into x squared, we're going to get 36, right? So the point b is going to be 6 comma 36. And then we're going to look, okay, what is the gradient of AB? Well, the rise over the run would be the, point B, 36, y, minus 4, which is the y of the A point. And then we're going to divide that by 6 minus 2, right? So that's basically going to give us 32 divided by 4, okay, which is 8, right? Okay, so that would be 8. 32 divided by 4. And then let's calculate point B if x equals 4. Then it would be 4 squared, which is 16. Okay, so on the top we'll have 16 minus 4, and we'll divide that by 4 minus 2, which is 2. Okay, so that'll be 12 divided by 2, which is 6. Okay, what about the point B, 3 comma, and it's 9, because 3 squared is 9. We'll have 9 minus 4 divided by 3 minus 2. So that would be 5 divided by 1. So the slope would be 5. The gradient would be 5. What about 2.5? Ooh, this is getting kind of harder. 2.5 comma 2.5 squared is, let me use the offline calculator because it's faster. 2.5 times 2.5 equals 6.25. So here we're going to have 6.25 minus 4, and we're going to divide it by 2.5 minus 2. So the top we're going to have 2.25 divided by 0.5, and that'll give us 4.5. Okay, and then we're going to get even harder here. 2.1 squared. We'll have 4.41. Okay, and then so we'll have 4.41 minus 4 divided by 2.1 minus 2. Okay, so 4.41 minus 4.41 divided by 2.1 minus 2 is going to be 0.1. It's going to be 4.1. Okay? All right. Well, the next one is 2.01. I'm going to have to expand this a little bit to write smaller. 2.01, and then 2.01 squared is 4.0401, but we'll just write 4.04 because the IB is happy with 3 significant figures. And then the subtraction we do here is 4.04 minus 4, and then in the denominator we're going to do 2.01 minus 2, and so our slope is going to be 0.04 divided by 0.01 gives us basically 4. It's a little bit bigger because I chopped off some figures there, but we already have gotten to a nice round figure of 4, coincidentally. Okay, so the gradient, when we make the chord very, very small, and when we make the chord, basically 0.01 long, the gradient happens to be 4. Okay, now let's try going from the left. So now the point B is going to be 0, 0. And so now we're going to find the gradient here. We're going to take, if, we don't have to do B minus A, we could do A minus B, because then we would get positive numbers. Either way, we're going to get the same thing, because negative numbers by the negative numbers give you a positive number anyway. So we'll take the a value y, which is 4. We're going to subtract 0, and we're going to divide it by 2 minus 0, and that'll give us 2, right? So that's our first estimate for the gradient of the tangent, but actually this is the gradient of the chord, okay? Then we're going to do the next point, which is going to be 1 comma 1. So we'll say 4 minus 1 divided by 2 minus 1 is equal to 3 divided by 1, which is 3. Point B, let's see, we're going to have 1.5, and 1.5 squared is 2.25, so the y value is 2.25. And then we're going to say 4 minus 2.25 divided by 1.5 minus 1 is equal to, let's see, 4 minus 2.25 is equal to 1.75. And that's divided by 0.5. And that gives us 3.5. Okay. Next one is 1.9. So the coordinates for 1.9 would be 1.9 for the x coordinate, and then for the y coordinate, 1.9 squared, which is 3.61. So here we had 4 minus 3.61 divided by 2. Oh, you know what? I did something wrong here. Look what I did wrong. It's not 1.5 minus 1. It's 2 minus 1.5, but it still gives us 0.5 there, okay? And then here it will be 2 minus 1.9, so that would give me 4 minus 3.69 is 0.39, divided by 2 minus 1.9 is 0.1, which would give me 0.39 divided by 0.1, which is going to be 3.9. Then next one, 1.99, and then the x value, or the y value, would be 1.99 times 1.99, which is 1.99 squared. It would be 3.9601. I'm just going to write 3.96. Leave off a couple of digits. So that would be 4 minus 3.96 in the numerator, and the denominator would be 2 minus 1.99. That would be 0.04 divided by 0.01, which is equal to 4. Okay, we've already reached the same value we did over here. It's also 4. Now we're going to do 1.999. And now I think my puny calculator is not going to even be able to detect the difference between the previous one. It's going to be 3.996. You see, you don't really have to go that far before you're already basically calculating the gradient of the tangent. 4 minus 3.996 in the numerator, and the denominator 2 minus 1.999, which in the denominator is going to be 0.001. In the numerator, it's going to be 4 minus 3.996, which is 0.004. 4 again, okay? And do you see how, like, when we're approaching, when we have the b value on the left of the AB, of point A, then we have this chord. I'm going to draw the chord in brown. Okay, if we start with this chord, then we can see that it starts with a lower slope. It starts with a slope of about 2, and then the closer we move B to A, it starts rising until finally, when it gets very close to A, it gives us a slope of 4. And when we start from the right side, it's kind of the opposite. It starts with a higher slope of 8, and then as we move B closer and closer to A, then we're going to see that the slope gradually gets smaller and smaller until, hey, it gets 4 also. So like, and we can see that even if we move fairly close, 2.1, or fairly close, like 1.99, we're already getting, or 1.9, we're already getting 3.9, 4.1. We can already guess that we are going to meet in the middle there and get 4, right? So our guess of the gradient of the tangent at the point 2, 4 is going to be 4, because, you know, that's the estimate we have going from the left and from the right. and it's not even really an estimate anymore. When we get 2.01 or 1.999 close, we're already basically on 4. We've already, considering only 3 significant figures, the value is 4. Okay, now finally, B. Evaluate the limit as x approaches 2 of x squared minus 4 divided by x minus 2, and provide a geometric interpretation of this result. Okay, well, basically this is kind of what we were doing up here above, right? Because what we were doing was, you can always see that, like, when we were doing our subtractions here, we were always subtracting 4 and 2, 4 and 2, or like 4 and 2. We were always finding the difference between 4 and 2, just like we were here. So that's exactly what we were doing. We were taking the x value in the denominator and the x squared value in the numerator. So, our value for this limit is going to be 4. And the geometric interpretation of this result is exactly what we're doing above. We made a chord where the distance between the 2 points on the chord, was we were just taking it to 0, right? We're taking the value of x of the b coordinate to 2. Okay, so we had the a coordinate and the b coordinate. The a value was already on 2, and so we were just taking the b value and we were also moving it to 2. So that's the x value there, right? And so we were just moving it closer and closer to the a value. When the chord finally reaches the a value, then it becomes the gradient of the tangent, which is 4. Okay? So that's one way to kind of understand where the derivative or the gradient of the tangent comes from.